Hi, my name's Dr. Barry Flannery. I'm the founder and CEO here at Xerotech. Welcome to another episode of XT Tech Talks. Today we're going to talk about the differences between diesel and electric. More specifically, diesel-powered equipment and electric-powered equipment that's been powered by a battery pack, similar to the ones that we supply here at Xerotech. So the first thing to understand about batteries is that they store energy. They store electrical energy. So as we spoke in previous videos, a typical cylindrical cell 2170 might have 18 watt hours in the most highest energy density typically available cells today. So that's 18 watt hours. It might weigh about 70 grams. So we sell batteries here at Xerotech, but we'll be the first to say that in terms of storing energy, batteries suck. They're really, really bad. They're terrible compared to diesel fuel and other petrochemical fuels. So just to understand how big of a difference there is, 18 watt hours in this little cylindrical cell, and that weighing 70 grams. If you had a liter of diesel, which is not in this case here, 1 liter will weigh, depending on, roughly about 800 grams. In general, diesel has about 10,000 watt hours in that volume, or roughly speaking, it's about 13 kilowatt hours per kilogram. Depends on the fuel, but broad strokes. The key difference here is that for the best lithium-ion energy density cells in the market today, it's about 280 watt hours per kilogram. So you're comparing lithium-ion, 280 watt hours per kilogram, with diesel, just to make the numbers round, 10,000 watt hours, 10, 11, 13,000 watt hours per kilogram. There is an order of magnitude difference here in the amount of energy that is stored between the two fuels. So it's very hard for a battery to directly match a diesel engine machine today because there's such an abundance of energy in that fuel. Diesel machines don't have to worry about efficiency. The fuel is extremely cheap compared to batteries. So you might wonder, how could you ever compare the two? How will batteries ever replace diesel machines? And the way that's possible is battery electric is much more efficient. So when we talk about energy here, this watt hours per kilogram is electrical. This 10,000 watt hours is chemical. So a diesel engine is a type of heat engine. The purpose of a heat engine is to take thermal energy and convert it into mechanical work. And any heat engine has an efficiency associated with it. Typically, a diesel engine would have an efficiency of about 30%, but for bigger diesel engines, it could be 40%. And for some of the biggest diesel engines in the world, it could be nearly as high as 50%. But in general, 30% to 40% is an average diesel engine efficiency. So a rule of thumb for engines is 1/3 of the energy that goes in comes out as mechanical shaft work, 1/3 goes out the radiator of the engine, and the other 1/3 goes out the exhaust pipe. So that's usually a breakdown of fuels in an engine. So you start then with our 10,000 watt hours is now already down to 3,000 watt hours per kilogram. So we've lost a lot of it already before we've even started. The next piece that matters is that's 3,000 watt hours driving a shaft. So if we have to then go to an electric motor or a generator, that will have further efficiencies if we're not directly driving wheels. So that might be 90% efficient. So again, you're losing more energy to convert it into electricity. And as we go further down the chain, if we want to convert it into hydraulics, we will only have an 80% efficiency. So again, you're slowly chipping away at the efficiency of the system as you start to get to something that compares it to a battery. Whereas when you look at a battery system that's 280 watt hours per kilogram, if you have a 100 kilowatt hour battery, that can be converted into 90+% efficiency through an electric motor. And a power electronics converter could be as high as 95% depending on the system. So you get a very high efficiency of the overall system here, 95 kilowatt hours. So that's why it's not as big of a gulf between diesel and electric machines as one might initially think. But the thing is that there is still a difference. So that's where you have to design your electric machines very differently to your diesel machines. You care about the efficiency all across the system. And it's unlikely that you're going to be using a battery in the exact same way you use a diesel machine. Because a diesel machine could comfortably run for 12 hours, 24 hours, wasting a lot of energy because it's got such an amount of energy in the system. Whereas a battery machine needs to be perfectly sized and it needs to be super lean and efficient to make sure it does all the usable work that it possibly is expected from the system. In the type of businesses and markets that we operate in, it can be surprising. The electric machines tend to be able to do quite a lot, but there's a lot of different applications. Even in the heavy duty space, when you're trying to compare a diesel application to electric, there's different types. So you can end up with a machine that's just a pure battery machine, and it might be just doing slow charging. So this is something that maybe for the application, it's able to be charged up at the start of the shift before the thing starts. It works for a full day, then it's done, and it's left charged overnight. Maybe that's okay. Other applications, they might need to use fast charging, where it has to work for 4 hours and then it stops for lunch, charges up in 30 minutes, and it does another 4 hours, doing a full shift before it does an overnight charge or move to a different one. The next type of application is dynamic charging. So dynamic charging is when you're using the battery while charging it. So you might see trains and trams that have overhead pantographs that connect up to high voltage lines. These are charging the batteries as they operate, so when they no longer have access to the power, they can basically drive to the next area and be used. So for example, in heavy surface pit mining, they have large pantographs that lift up and connect to high voltage lines, and they drive up the slopes, charging as they go up the slopes, delivering more power. And then once they're away from the transmission lines, they're able to use battery for that piece of a distance. The next piece then is battery swapping. So if you can't wait 30 minutes or 4 hours or 8 hours, some applications actually swap the battery in a minute or 2 minutes, taking up a new battery that has been charged previously. So battery swapping can be used for other heavy duty applications or ones that work, or even very small, simple applications, for example, e-bikes and things like that, where a battery can just be taken out and put back in. The final one then is a tethered application. So some machines, particularly in heavy duty industrial sectors, are effectively plugged in on giant extension leads. So the battery application is to drive it to the next extension lead. It stops, it's parked, and it's going to be drilling away or doing whatever it might be doing for 10 hours, a week, however long it might be. So the important thing here when we talk about electrification of all these segments is there's a lot of different applications and ways that it can get done. And the other pieces outside of just pure EV, there's also hydrogen, and then there's fuels like diesel. So when it comes to hydrogen, there's two types, things that you have to consider. You've got the fuel cells, and then you've got the internal combustion engines. So for fuel cells, most people might ask a question, oh, but what about hydrogen? Batteries won't happen, it's going to be hydrogen. A very important thing to understand is that every fuel cell vehicle in the world is a battery electric vehicle. We at Xerotech have many fuel cell customers. So fuel cells can only really run at steady states. They don't like to ramp up quickly or drop down quickly. They're very base load power. So they put batteries in conjunction with the fuel cell to deliver that dynamic power. So we like hydrogen, we think it's great, we think fuel cells are great. They are a customer of ours. They buy and use battery cells. The advantage of hydrogen is that it's a very energy dense fuel, but the disadvantage is that it has very poor availability and it's quite challenging to store it, which also makes it quite expensive. So hydrogen infrastructure and hydrogen fuel cells are still in active development. We do see them in certain applications, but there's quite a journey to go, especially in comparison to battery electric systems, where the automotive industry is really driving forward and making these systems much more cheaply available. The other piece for hydrogen is much closer to a diesel engine, is that using hydrogen in an engine and just simply burning it, as opposed to putting it through a fuel cell and converting it into electricity. So a fuel cell system is much higher efficiency because you're going from hydrogen to electricity, whereas a hydrogen burning engine is burning the hydrogen to drive a shaft, then drive a generator. Hydrogen fuel cell engines have lower efficiency than diesel engines and do face some challenges again around the storage of hydrogen and also material science issues, hydrogen embrittlement and other aspects like that that make it challenging. And then when it comes to diesel, there are still clean ways or cleaner ways of doing diesel using biofuels, using zero carbon fuels. So our perspective is that you're going to see all of the above here in the future. There will be different applications depending on the end user application and the part of the world that it's actually in. But we do expect that as we look forward over the next 20, 30 years, EV is likely to become the mass dominant form of power for all applications, irrespective of where they are. But there will absolutely be other types. So now that we've gone through the most fundamental aspects of the energy difference between fuel cells, batteries, engines, and all the different types, why would someone want to use a battery vehicle or an electric vehicle over a conventional machine? So I said at the very beginning, batteries are terrible. Batteries are really bad at storing energy. But what's very attractive about electric drivetrains is the electric motor. The electric motor is by far the best and most powerful thing we've ever created. And what I mean by that is it's basically 100% efficient. It never breaks, and its power density is many multiples that of a diesel engine. So the goal here is to use motors. However we power them, we'll just use the best things we have available. So if we fast forward 100 years in the future or hundreds of years in the future, I don't know what's going to be powering those machines, but I do know it'll be an electric motor that's driving it. So the motor is the key thing here. And if anyone that's driven an electric car, you've probably seen that you get very high performance out of electric machines. So that has to do with the power and the torque. So this is basically the torque or the turning power of the motor versus the speed. So motors, you might have heard, have full torque at low RPM, whereas an engine, so this is a motor, this is an engine, the torque curve will have to build up like this. So that means that for an electric machine, when it's standing still like a car, it has full power from instant. So this makes them very fun and exciting to drive. But apart from being exciting to drive, it makes them much more efficient machines. So in a practical case, for some of our customers in the mining industry, the electric heavy duty machines, these massive 100-ton machines and 50-ton machines, they're 50% faster than the diesel machines because they have much higher peak power. They can go up steeper slopes. They produce less heat. They produce no noise. They produce no emissions. And of course, this is the big overarching reason for the shift for electrification, is looking past the climate change and the carbon emission side, the diesel particulates, the exhaust, the NOx, all the other pollutants. These can be big challenges in parts of the world and in certain applications like indoor construction, like underground mining. So moving to full electric drivetrains, it reduces noise, it reduces heat, it reduces ambient air emissions of diesel turbochargers stirring up dust in mine sites. It makes it a much more enjoyable machine to drive because you have better responsiveness, better performance, lower vibration. So these are strong drivers to go electric. The goal is to find the right applications, find the right system design or system architecture to enable you to use an electric machine. The final piece is that diesel won't be going away anytime soon. It's going to be shifting to diesel hybrid, so starting to use the benefits of diesel and basically take this, extend it using hybridization, using batteries to do peak power, using diesel electric propulsion. And the other thing that I always try and instill in the company here is diesel is not the bad guy. We're standing on the shoulders of giants being diesel engines, and diesel is now passing the torch on to batteries and electric motors to bring us into the future. So it's very important to understand the right use cases for battery electric machines, and they will continue to grow and grow as the technology improves. But it's important to understand again that the difference between diesel fuel or liquid fuels and batteries is huge. There's a massive gulf between those two energy sources. And even with all the improvements and developments with batteries, that's only going to close it a little bit. There will always be a fundamental difference there for many years. So it's about sizing the right applications. So some of the other important differences between a diesel powertrain or a diesel driveline and an electric driveline is diesel engines have a lot more mechanical parts, a lot more moving components. They need a lot more lubrication. They have oil filters, air filters, many other aspects. So by going to electric machines, electric motors and batteries, you eliminate a whole host of components. Basically, there's very little to almost no maintenance on an electric machine. So the operating costs are much lower. And what's attractive then is that once you're using the machines, because they're so much more efficient, you might recall we spoke about a diesel powertrain being roughly 30% and an electric being roughly 90%. Effectively, diesel machines will cost about 3 times as much to run as an electric machine once you're actually using and operating it. So the total operating cost is much, much lower. The reliability, the performance of the electric machines is much, much higher. That's why it's quite attractive now to use these electric machines. And when it comes to safety, there's been a lot of questions around battery safety, battery fires. And batteries can and do fail, and they can go on fire. But I guess the difference to look at is what's the rate of battery fires versus the rate of diesel fires for a given standardized amount of time, be it miles driven, hours used. And what's very clear, and you can look at this data from the Norwegian automotive market, it's about 90+% lower for electric machines. And I'm not surprised because there's far less that can go wrong in those machines. And something that's overlooked with diesel equipment or petrol or any other liquid fuel is that the fuel is highly combustible. I mean, there's nobody going to argue that putting a match into diesel or petrol is going to result in a bad thing. It's going to result in fire. And diesel does burn. This is a big thing that we encounter in our space, is that this assumption that diesel doesn't burn, that you can flick a match into it and it'll go out. Sometimes it'll burn on the surface and it can continue to burn. So it really depends on the case. This is one area where the advantages of being a lower energy density fuel actually help you, because if you're to take our cylindrical battery cells, roughly speaking, around 10 to 12 battery cells is equivalent to 1 shot glass of diesel in terms of thermal energy. So that's why it's quite important that basically we're isolating up in a large system. You'll have a huge fuel tank with 800 liters of all that energy. Imagine the amount of energy. It's megawatt hours of energy in that system. Whereas with a battery, we're isolating it into tiny little units, all encased in steel, generally speaking, insulated, or in the case of a Xerotech battery, encased in steel and then wrapped in fire retardant insulating foam. So this makes the system extremely robust, extremely safe compared to conventional diesel machines. So the safety element, both systems have unique safety challenges. Both systems have pros and cons, but overall, if we were to invent diesel engines today, it's unlikely they'd be allowed on safety grounds to be going around with highly combustible fuels at 60 or 80 miles an hour on a motorway sitting on top of it. Whereas a battery system offers much higher levels of safety compared to what the market has accepted today. And the final piece to understand is in relation to batteries and battery fires. There will be fires, and unfortunately there may even be fatalities related to battery fires. But the question is it as safe or more safe than what's currently used today? Because if it is, we have a responsibility as society to implement that technology, because the damage of diesel or internal combustion engines is much broader. It's impacting the planet, it's impacting the ecosystem and the air that we breathe. So that is a very hidden but very real damaging effect. So I hope you found that somewhat useful to understand the differences between diesel equipment and electric machines. There's a role for both in the world today, and there will be into the future. Thanks very much for listening.